Okay, we're doing propositional logic part 3 with Sparrow. Um, so we already started like revising a bit. So yeah, let's start.
What's up? So
What's up?
yeah,
What's up?
I was reading the biconditional truth table.
Before we go, do you want like $10?
Why do I want $10? Huh?
It's a homeless guy joke, but okay.
Oh, like that. I haven't cut my hair or I like shaved in a long, long time.
Nice.
It's been over 2 weeks. So yeah. Biconditional
Yeah.
P P implies Q will be uh P implies Q will be false only when P is true and Q is false. So
Hmm.
that's why it's false here.
Yeah.
And Q implies P will be false only when Q is false and P is sorry, Q is true and P is false.
Hmm.
So that is false here. And then the and of this or the conjunction of this is if both are true, it is true. If both are true, it is true. If even one is false, it is false.
Yeah.
So 1001, and if and only if is true if either both conditions are false or both conditions are true.
Oh,
These
it's
are
true when
biconditional.
it is when both of them are either false or
Yeah,
yeah. Hmm.
false or true.
Yeah.
So like um, if give me an example when both are false. No?
Sparrow is a rat. If Sparrow is a rat, if and only if the sky is black.
Blue, black. That's true.
So the biconditional is true, but neither of the like neither P nor Q is true.
Right. It's like a negation of a negation is a positive.
Something like that.
Yeah. Negative into negative is positive. Okay. After that, we did this tautology thing here,
Hmm.
but to get to that, we did P and negation of Q,
Hmm.
and then PQ, and then P and negation of Q we did,
Right.
and
What
then we
is
did
P and
P.
not Q?
That's a implication.
P and not
Material
Q
implication.
is negation of material implication.
Negation of material implication. I was close enough. Not bad. I
Yeah,
kind of
yeah, yeah.
remembered that.
Not bad at all.
Yeah. That was a negation of a material implication. Oh yeah, true. I just seen it and I figured it out. And then P and not P,
Hmm.
truth table for a contradiction,
Hmm.
and P or not P is a tautology.
Hmm. What's the difference between tautology and contradiction?
Contradiction is just contradiction is the
In terms of like the
contradiction
truth
is
table.
they're just it's the negation. Negation of tautology is a contradiction.
Right, but in terms of like what truth values the column occupies. Sorry,
A
what?
tautology
Huh.
tautology is always true.
Yeah,
Contradiction is always false.
right.
But what exactly is a tautology? Can you give me a natural language example?
Yeah, like you could say either Sparrow is a rat or Sparrow is not a rat. It's
Right,
always true. Like,
right.
yeah, either you are a rat or you're not a rat. Like, one of them is always true. And since it's a disjunction, even if one is true, the entire thing is true.
Hmm. Whereas the contradiction will be either sparrow is a rat and sparrow is not a rat.
There is no
Both will be
either.
false.
So, Sparrow is a rat and
Yeah,
Sparrow
yeah.
is
There
not
is
a
a
rat.
rat, not a rat. Yeah.
Yeah, so there is no column where both of them are true simultaneously. So all the entire column will be false.
Hmm. And then we did material implication. Yeah, material implication, I remember antecedent, consequent,
Hmm.
disjunction, conjunction, and negation.
Yeah, those things
There
are
are
pretty
five.
basic. Yeah. Yeah, yeah.
Yeah,
Go ahead.
negation, disjunction, conjunction, material implication, and double implication.
Yeah,
Biconditional.
biconditional double implication, same thing.
Yeah.
There is also like subtypes of disjunction, which is like exclusive disjunction, inclusive disjunction.
Mm-hmm.
Inclusive disjunction is just the V. Exclusive disjunction is V with an underline.
Underline. Okay.
Have
Let
have we
me
done that? I think we have done that.
We haven't. I think you mentioned that it exists, but I don't think we did it before.
Can you? Okay. Basically, exclusive disjunction is um, like both of them have to have different truth values. Like p x or q would only be true if either p is true or q is true. Like if both of them are true or both of them are false, it is false.
Okay, so this is what kind of disjunction again?
Exclusive disjunction. It excludes the case where both of them are true. So that's why it's
Okay.
exclusive. Inclusive
Exclusive.
includes the case where both of them are true. That's why it's called an inclusive disjunction. So
Right.
a regular or is inclusive disjunction. Uh, Exclusive disjunction is when you use an x or.
XOR. Okay.
X and or. X or.
Yeah. So P, Q, and then exclusive disjunction is with a V with an underline, right?
V with an underline, right?
Q. So if I do 0011 and 0101, if both of them are true, also it is false.
Yeah.
That's the exclusive disjunction. So this will be an exclusive disjunction.
Yeah. So this looks like the negation of what?
It looks like the negation of a biconditional.
Yeah.
Yeah, so like if and only if would never be an exclusive disjunction, right?
What?
If and only if is never an exclusive disjunction, is a negation of an exclusive disjunction.
Right.
Wait, let me fix my hair. Go ahead, continue.
Yeah. So yeah, I guess we are like done with all the operations.
Wait, inclusive disjunction is the same as
Or.
or, and it's just or, right?
Yeah, or has two types, inclusive and exclusive. The regular one is inclusive, where
Right.
you like where both of them, when they are true, it is also true.
Got it.
Exclusive excludes the case where both of them are true. That's why it's called exclusive.
Do you hear my chair squeaking?
No.
Okay, sweet. GG with the
Crisp.
voice. Crisp, yeah.
Crisp, yeah.
Okay, cool. Let's move on.
Okay. So, just like some basic this thing again, what's an argument?
An argument is a set of premises.
Premises. That's all?
Premises. Leading to a conclusion.
Yeah, so it is like it has two elements, the premises and the conclusion, and the
Yeah.
conclusion is supposed to follow from the premises.
Yeah.
What is logic?
It's a logic is the study of arguments.
Right. So if you just replace the term argument with whatever you said, what would logic be?
With the term with what I said with premises,
Yeah, like
it'll be a proposition.
no. Like logic is a study of arguments, right?
You're right.
So what is an argument?
Oh, an argument is a set of premises that lead to a conclusion.
Yeah, so what is logic if you replace argument with that definition?
An argument is a logic is a study of a set of propositions leading to a conclusion.
Right. But yeah, I mean yeah, right. Like but the thing is that we just like we don't like it's generally just that logic just studies um arguments, reasoning, etc. So it's yeah, just like yeah. Anyway, so from here, I guess the conventional trajectory is to teach rules of inference, where like now I've taught you all the operations. I've taught you the truth tables, etc. I've showed you how to draw truth tables, etc. So conventionally, what people do is they will teach rules of inference next. So, but I just want to conduct like a small pedagogical experiment where I'll just
What was that word again? Pedagogical.
yeah, that's
I think pedagogy.
Is
Pedagogically.
pedagogical?
I think what's that?
Okay, I guess. Anyway, yeah, basically is like pedagogy is just teaching, right? So,
Mm.
uh, but yeah, like I want to conduct an experiment, like just to see whether it makes a difference. If it makes a difference, then we'll go back to learning rules of inference. But the experiment is, instead of teaching um, rules of inference first, I'll be teaching you rules of replacement, or rules
Mm.
of like it's called rules of replacement, or it's called rules of equivalence. So yeah, I guess so. Like I think we are already kind of doing a little bit of rules of replacement. uh, like for example, when I was explaining the this thing, material implication,
Mm.
we derived the negation of material implication, which was what?
Uh, I know this. I know this. It's right here.
Yeah, you know it, of course.
It's a contradiction. No, wait, no.
No, it's not. When is a material implication false?
When the antecedent is true and the consequent is false.
Right. So if the antecedent is P and the consequent is false, what is the negation of an implication?
Sorry, if the antecedent is false and
P.
negation is true.
Yeah. Negation. Consequent is true. No. Antecedent is true. Consequent is false. That's the
Yeah.
negation
Yeah.
of a material implication. So if the implication is as P implies Q, what is not P implies Q?
I'm confused. I don't know what you mean.
So
So wait, you said if the antecedent is true and the consequent is false.
that is when the
The
implication is false.
implication is false. True.
And
That's right.
when we are saying uh, what is the negation of an implication, we are just asking the same question. Like we are just asking when is it false.
Right. Yeah.
So it's false when.
It's false when the antecedent is false, and then so if the antecedent is true and the consequent is false.
Right. So how do you write that symbolically for P implies Q?
Negation of P implies Q.
Negation of P implies Q. What does that entail?
P and not Q.
Right. So
Okay.
that is one kind of replacement. So um, whenever you have not P implies Q, you can simply replace it with P and not
Negation.
Q. So because it's called analytic entailment. Like it's just true by form. Like whatever the meaning of the terms is. So when we are saying negation of P implies Q, what we are like what it actually means is, what is it when P implies Q is false, which is just like it's just going to be P and not Q. So that's one kind of replacement. The other kind of replacement is uh, P implies Q. So we can let's go one by one. So we are talking about P implies Q. So
Wait, so I have a question.
yeah.
So this is correct, right? So negation of P implies Q
Yeah.
is equal to P and not Q.
Yeah.
But if I were to think about, so the reason I'm very confused is because I'm thinking of this from a mathematical perspective, right? So I'm thinking of negation of P implies negation of Q. So I'm just big, how brackets, when I open the brackets,
Oh, yeah.
I have this
I
both
see what
sides.
you mean. Yeah. Don't do
So I'm
that.
very
So
confused by that. Don't do that.
yeah. So there are rules for that.
Okay.
We'll get there. So
Okay.
there are distributive rules.
Oh, I just have to memorize this. I don't have to try and deduce this
No, you can
by.
deduce it. Like when you have
Okay.
P implies Q,
Mm.
negation of P implies Q just means what? Negation of P implies Q means P implies Q is false.
Yeah.
So when is P implies Q false? When P is Q and Q is false.
Right.
And false
Right.
just means not. So
Yeah.
it's P and
Not
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 Q.
true. then okay.
So you can deduce it like on the spot, like just looking
Yeah,
at
but
it.
it's more like a natural language deduction, right? I was thinking of more of a logical deduction. If I had that right now itself, it'll be easier for me to remember
Mm-hmm.
rather than trying to memorize this or trying to create what you just did, the
Hmm.
deduction that you just did in the head using natural language. If I do it via logic, it'll be easier for me to remember. So we'll do that. We'll do that later.
Well, we are doing it with logic. Like you can do this with a with a truth table.
Yeah, that's what I would. Yeah, that's what I would like. I think we already done that.
We have already done that.
Yeah.
Where we did like we negated P implies
Yeah,
Q.
we've already done this here. So
Right.
P implies Q,
Yeah.
negation of P implies Q, and then
Yep.
P and not Q.
Yeah. That's how you yeah, that's how you derive an equivalence.
Yeah.
So that's one kind of equivalence. Now I want you to derive like now I've given you what the negation of this thing is, right? Like the negation of what do you call it? Material implication is a P and negation of P implies Q is P and not Q. Now from this we can actually derive something like how would you replace uh, P implies Q? Like P implies Q also means something. Like it equals something. That's what we are going to derive now. So the first thing, like there is a rule of replacement, and the first rule that we are going to look at is called De Morgan's law.
Okay.
So you can write that down.
What's this date? 20th. D. Morgan, right?
De Morgan's law.
Morgan. So got that. Yeah.
Yeah, like I think some people like the proper pronunciation is De Morgan's law or something like that. I don't know,
Okay.
but yeah,
Yeah.
De Morgan's law, whatever.
Let's say De Morgan's law.
Yeah, let's make him Bengali. But yeah,
Yeah.
so there are two laws under
Mhm.
De Morgan's laws. The
Okay.
first applies to conjunction, negation of conjunction, and the second applies to negation of disjunction. De Morgan's law does not apply to any other operator. It only applies to um, conjunction and disjunction. So what it is going to be is you write a negation symbol, and then inside brackets you write some conjunction like P and Q or something.
Okay.
And now like okay, so whenever you're doing like replacement, instead of using an equal to symbol, what you can use is just like a double implication, like a biconditional,
Okay.
because
Okay.
like, yeah, there is no equal symbol in like prop logic.
Mm-hmm.
The symbol is going to be like a biconditional.
Mm-hmm.
So you write P inside.
Well, conditional. If, if and only if. So if and only
Yeah,
if, or if and only if this set is true, that set will also be true.
right. So if this is like if the first part of the biconditional is true, the second one has
Right.
to be true.
Mm-hmm. Right.
Okay.
Okay.
So we had okay. So that's the first one, which is conjunction. So you write a negation symbol, and inside brackets you have a conjunct.
Yeah.
And
P and Q.
right. So what you're doing over here is you're negating a conjunct.
Right. Okay.
And what that means is you're just going to negate all the symbols inside. So you're going to negate P, so there'll be negation of P,
Mm-hmm.
and then you'll have instead of an and you will have
Be
an
or.
or. Yeah. And
Negation
then
of P or negation of Q.
right.
Okay. So it's like when I see negation of P or negation of Q in a logical statement, I can just replace that with negation of P and Q. It's like simplifying an
Can
equation.
can you repeat that?
So if I find negation of P
Hmm.
or
Hmm.
negation of Q
Right.
in a let's say proposition logical in a statement,
Right.
I can just replace that with negation of in brackets P and Q.
Yes,
It's
yes,
simplifying. It's like simplifying the statement.
yes, you can.
Right.
That's the point of replacement.
No.
So yeah, so that is when you have like this. When you have a negation of a conjunct, you can replace it with not P or not Q. Now let's say instead of a conjunct you have a disjunct. So let's say you
Well, let me try to see if this is the obvious thing, right?
yeah.
So the negation, it will be a negation in brackets P disjunct Q,
Hmm.
and that will
Or
be a double
Q.
implication.
Hmm.
It will be a double implication. It will be negation of P and negation of Q.
Right. So that's the second
Okay.
De Morgan's law.
Okay.
So
This is
yeah,
called
that's
negating a disjunct.
it's called negating a disjunct.
Sweet.
So this is De Morgan's law. It applies to conjuncts and disjuncts. I think what you were doing previously was you were
Kind of this, yeah.
kind of this, right? So you were
Yeah.
trying to apply you're
Yeah,
thinking of
yeah,
De Morgan's law in terms of like a material implication.
yeah.
Um, okay, so now let's go back to that.
Wait, one sec.
Hmm.
Okay, going back to that. Negation of material implication, I've said equals to. I could replace that equal to symbol with a double implication, right?
Yes, yes.
Okay.
So let's go. Yeah, we'll just go back to that. So now you have negation of P implies Q.
Right.
Double implies P and not Q, right?
Yeah.
Now, what if you remove that negation symbol from the LHS and you put it to the RHS? What will it be? So basically,
You mean, okay, wait, let me write this down again.
yeah, I'm asking you how would you replace P implies Q, given that I've taught you De Morgan's law.
Oh, okay, that's easy.
Yeah.
The negation of P implies Q would be, we already know this, right? It's P and not Q.
Right.
And we also know that P and not Q is the negation of P and not
No.
negation of P and Q is written here. It's already it's negating a conjunct.
No, but they like the negation is not equally distributed in P and not Q. Like only one of them is negated. Go back to the previous one.
Right.
Yeah, so here it is like the negation symbol is only there with the P and not Q.
Yeah.
So it's only there with Q
The
basically.
Q, not Q.
So you can't directly apply De Morgan's law. You have to do something
Mhm.
before that. So like in mathematics, what you do is you can take the like if you take the negation symbol from LHS to RHS,
Right.
what will happen?
So what will happen? It will become, in this scenario, if I take the negation from, okay, let me write this down. This negation of P and Q. So negation of P implies Q. P and not Q. Right? So I've written this down here.
Yeah.
And now you're saying if I take this negation and put it here basically.
Yeah.
Put on the other side. So if I put it directly, it'll be negation of P and Q. So P implies Q will be negation of P and
No, don't skip
wait.
steps. So
wait.
when you're taking the negation from LHS to RHS, you have to put it in a bracket, right?
Yeah.
So write that
Okay.
step.
Okay.
So what will the LHS?
P implies Q.
Okay. RHS?
RHS will be negation of whole P and not Q.
Right. Now apply De Morgan's law.
Like this.
Yeah, correct. Now apply De Morgan's law.
So it will be
P
negation
implies
of P.
P implies
Yeah,
Q
P
implies
implies Q.
double implies.
Double implies negation of P or Q.
Right.
Okay.
Yeah. So you have derived replacement of a material implication. So wherever you see a material implication, you can replace it with not P or Q. False antecedent, true consequent.
Right.
Now try negating. So now you have false antecedent, true consequent. What will be the negation of that?
Sorry, you have a false antecedent to consequent, right?
What will be the
And
negation
negation
of
of
that?
a negation of a negation of. Okay, you want me to
Not,
just.
yeah, not P or Q. Like you just apply De Morgan's law all over again.
Okay, so okay, negation of. Okay, so
Yeah, so it'll be
basically
P and
you're
not Q.
asking me to. You're asking me to put that. You're asking me to put negation over this whole thing, right?
Yeah, and yeah,
So it'll
basically.
be it'll be P or it'll be P and not Q.
Right. So you get back
It'll be
that.
this.
Right. And that means,
That'll be this.
yep.
Right.
Okay. So you like, yeah, basically that's one, again, that's another replacement. It's called negated conditional or negated implication.
Negated
Yeah.
implication. Okay.
Negated
So
implication is just P and not Q. Uh,
negation
and
of an implication
hmm,
is just negation of P implies Q.
yeah,
What you just derived right now.
yeah.
And then you said there's another one. What is it? Or what did you just say right now?
W-
The one that we just did right now. Negation of not P implies Q. Not P or Q.
Not P or Q. That's, yeah, that's
Yeah.
negated conditional.
Yeah.
I
No,
don't.
but you want me to put negation of that.
No,
Negation
like I'm
of.
just, no, I don't want you to do it right now. I'm just like,
Okay, okay.
yeah, just for the sake of illustration, if you just put a
Mhm.
negation there, you'll just get the previous one again.
Previously, yeah.
Yeah.
Mhm.
So negation of implication is P and not Q. Implication is not P or Q.
Right.
So wherever you see an implication, what will you replace? Like you don't have to replace it. Sometimes it's useful to replace it.
Mhm.
But what can it be replaced with?
When I say an implication, I can replace it with P and not Q.
No.
When I say an implication,
Hmm.
yeah, an implication is P and not Q, right?
No, check again. What is an implication? You just derived it.
Wait, not P and Q, not P or Q
Not P or Q.
or Q.
Now think of
Right.
this in terms of the truth
Oh,
table.
I'm thinking of the negation of an implication.
Yeah, yeah, yeah.
Right, right.
So an implication is not P or Q.
Right.
Now think
Right,
of
right.
this in terms of the truth table. Open the truth, like keep this in mind, like not P or Q, and then open the truth table for implication. I'll draw another one. Let's draw another truth table for implication.
Okay. So what do I need? I need P, Q, and P implies Q, right?
Yeah. And then draw a fourth column where it would be not P or Q.
P, Q, P implies Q, and not P or Q. P0011, Q0101, P implies Q is false only when the antecedent is true and the consequent is false.
Right.
So apart from that, everything else is true and not P or Q. Okay, so I've done this.
Yeah. Now
Right.
find out not P or Q.
Not P or Q should be the same thing, right? I mean,
Yeah.
we've derived that.
Yeah,
We've derived that.
yeah, I just want you to do it with truth table also so that it gets solidified.
Oh, okay. So let me then let me have to derive it, make it simpler. Let me put another column of not P, so that will be 1100, and I'll then create another table where it's not P or Q. So I have not P here, I have Q here, so then I can just make the OR here. Right?
Yeah.
So not P, when it's an OR, it is true in all cases except for when both are false. So I'll just put the false there. It is true in all of the cases. So it is the same as P plus Q.
Right. Basically, they are equivalent.
Yeah.
And replaceable.
Yeah.
Okay.
Okay.
So that's De Morgan's law. So I think we have knocked out two or three of them actually. De Morgan's law. Oh no, four of them. De Morgan's law is two rules. Negated implication is one. Implication is the fourth one. So we have done 4 rules of
Oh.
replacement. So you maybe
Negation of conjunction, negation of disjunction, negation of implication, and implication.
right. We have done 4.
Right. Okay.
So maybe you want to like keep a, make a table or something like that, like, or write it like
Yeah.
on one page. You can write it like sequentially, like each of them.
Yeah, I've just written it down. So I've written it down here.
Yeah.
The first one is negation of conjunction, negation of disjunction,
Hmm.
negation of implication, and implication.
Right.
Oh, 4 De Morgan's laws.
Hmm.
De Morgan's laws.
Yeah.
Sweet.
Okay. Then we have associativity or association, as sometimes it's called.
So is this another De Morgan's law? Or is
No,
just
it's
something-
another type. It's another, like, it's not a De Morgan's law. It's
Okay.
another
Rule
rule of
replacement.
replacement. Right.
Rule of replacement. Okay.
Yeah.
So these 4 are De Morgan's laws, but they're also rules of replacement.
Right.
Right. Okay.
Well, these 4 are not De Morgan's. De Morgan's law is just the conjunction and the
negation. Okay.
yeah, negation of conjunction,
negation
negation
of
of
disjunction.
disjunction. Right. Those are the De Morgan's law. The other is an implication.
मैं एक easy way offer करूँ क्या De Morgan's laws के बारे में सोचने के लिए?
बोल.
So you can think of it like this. So disjunction, think of it like this. So A or B is basically saying at least one of A and B is true. है ना? If you're saying A or B,
Yeah. At least
that
one of them
means
is true.
at least one of them is true.
Yeah.
So when we say that it's false, when we say A or B is false, so we are basically saying it is false that at least one of them is true. So that
Okay.
means both of them are false.
Mhm.
So that's how you get not P and not Q.
Yeah. Similarly, for conjunction means A. If you say A and B,
A
that
and B
means
is both are true.
both of them are true.
Right.
So negating that would mean it's false that both of them are true.
True.
That means
Right.
at least one of them is false.
Right. Got it. Yeah, natural language helps sometimes.
Yeah. Yeah, that's an easy way. Like, that's a natural language way of thinking about this.
Yeah.
Mhm.
So
Right.
we have done 2 categories of rules of replacement. One is De Morgan's law, the other is implication, and then we are going to association.
Okay.
So each of these rules is going to have 2 of them. Okay, like each of them is like De Morgan's law is 2 laws, implication is 2 laws, association is 2 rules. What's the other one? Commutation is 2. Distribution is 2. Everything is like 2. Like, it's a pair of rules.
Right.
Okay. So yeah, let's go to association. So association is just going to be what you do is you write A, or like any propositional variable you want. You can write like A, B, C, or P, Q, or whatever. So you write P or, and then the Q or R you put in a bracket.
Q.
So you write A or B
Right.
or C.
But P or C in a bracket.
Yes.
So P or Q or R.
Right. Exactly.
Okay, got it.
Now this is equivalent to just the bracket shifting to the left.
Oh, okay. So P or Q in brackets,
Hmm.
whole or R.
Right.
Oh, okay.
This is association. It's pretty simple.
Right.
Now do you want to do an exercise where you're just going to derive this with truth table, or are you like
Yeah.
okay, then we can
I
do
mean,
it.
I mean, I want to, even though this is straightforward and easy, I want to derive it so that I understand derivations a lot more as we
Right.
practice. So first,
I mean, I'm going to get you to derive all of these things after we do rules of inference anyway, like in a formal proof
Okay.
system. But
Okay.
yeah, if you want to do it like a truth table, you can do it now. It's
Yes,
not.
that, yeah, truth table will do. So I'm going to do P, Q, and R. So P is 1100. Q is, I'll have to use 612, right?
Yeah, draw
I-
small boxes.
Wait, how many? 12, right?
No. You will need 1,
Eight.
2, 3. yeah, three propositional variables that you have. Then you need one table, two
No,
tables.
no. I mean, how many rows?
Oh, rows.
Almost. Yeah, yeah,
How
yeah.
to
So
how to find out the number of rows?
the number of variables, oh, 2 into the number of variables, 2
Two,
power of number of
yeah,
variables.
to power
So 8,
number of variables. Yeah,
8,
eight.
right? 1, 2, 3, 4, 5, 6. I got it. Okay. So one is P, Q, and R, and then I'm going to do Q. Then I'm going to do P and Q, and then I'm going to do Q and R, and then P and P or Q or R, and then P or Q or R.
Right.
I'm going to derive it like that.
Yeah.
So P, Q, R should be 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, then 0, 1, 0, 1, 0, 0, 1. Right? I got all the combinations. Sweet. Okay. And then I'm going to do P or Q. P or Q, I don't need all 8. I just need 4, right? Or wait, I need
No, you need all of them.
all. Okay. So P or Q will be true in all cases except for where both are false. So false, false, true, 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 true,
Do the
true,
false
true.
first and do all the trues. Just fill up all the trues.
Yeah. And then next will be Q or R. Again, this will be false where only both are false. So false and false. Everything else is true. And then now I got to do P or Q or R in brackets. So then again, that will be true only, that will be false only when both are false. So I'll P or Q or R. Okay, so only 1, 0. Everything else is 1. And then P or Q or R. P or Q is here, R is here, both are false. Everything else is true. Okay, yeah, they both are the same.
Yeah.
So P, Q, and R, and then P or Q, both are only the top two are only the top two have both false. So false, false, true, 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 true. Here Q and R false, false here. So these two are false. I think this is true. And in case of P or Q or R, these are false.
False.
Everything else is true.
Right.
And same thing with this.
Right.
So yeah.
Yeah. So that's the first association law. The second one is just going to replace all the ors with ands and everything else is same.
Oh, okay. So P and Q and R is double implies. What do I say? Is equivalent to
Yeah, you can say it's equivalent
P
to,
and
or you could say
Q.
yeah, yeah, equivalent is fine.
Okay, let me quickly derive this as well. 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. Sweet. Okay. P, Q, R. Then I'm going to do P and Q, Q and R. So P and Q will be true only when both are true. So I'll first put those in. Both are true here, here. Everything else is false. And then similarly with Q and R, both are true here and here, everything else is false. And then I'm going to do P and Q and R. So P and Q and R both are true only when. Okay, so this is true, everything else is false. Similarly, P and Q and R. So P and Q and R. Where is the both are true here. Yeah. So yeah,
Yeah.
PQR, P and Q, Q and R, P and Q and R. Only these two are only this and this are true. Similarly, this and this are true.
Right. Almost looks like you inverted the.
Yeah.
Yeah, looks very similar to the other table, right?
Yeah.
अपूर्वा वो XOR को क्या क्या था एक्सक्लूसिव डिसजंक्शन
Exclusive disjunction.
ओके
Yeah.
उसको ऐसे भी सोच सकते कि if you're saying A XOR B it means exactly one of them is true.
Yeah, exactly one of them is true. Only or
So
only one of them is true.
yeah
Basically,
like
yeah.
एक एनालॉगस सिचुएशन ऐसा होगा कि अगर एक रेस्टोरेंट में एक कॉम्प्लीमेंट्री ड्रिंक ऑफर कर रहे हैं like sir would you like to have beer or let's say mango juice. So he's basically saying you can either have beer or mango juice but
Right.
you can't have both.
Right.
Yeah.
So it's
Mango
like that you
juice
can
for
have
them.
yeah you can have exactly one of them.
Right.
Mhm.
So like that's why when we use like either or things like that, that usually signifies some kind of exclusive disjunction
Yeah, in natural language.
in natural language.
Mm.
But anyway, okay. So that's association that we have finished.
Yeah.
Let's do
So far we finished De Morgan's law, we finished negation of implication and association.
yeah, De Morgan's law. Implication is two, implication and its negation. Then we have finished association. So we have finished three categories. Do you have another hour?
I have another half an hour.
You have another half an hour. Okay, then fine. Yeah. Let's do distribution. I guess we will be able to finish the rules of replacement today.
Sweet. Okay.
Okay, let's do so association. So what's done? We have done De Morgan's association and implication. Okay, fine. Let's do distribution. So yeah, distribution is very similar to the other two, except that so you have let's say P, then you have and then the other Q or R isn't like it's a disjunction. Q or R is in a bracket.
Oh, okay. And then that implies P or Q in a bracket and R outside.
No.
Oh, so the bracket just shifts. So
The bracket doesn't shift here. That's why it's called so it's called distribution. So can you think what is going to be distributed?
Okay, so be P and Q or P and R.
Exactly.
This is maths, no?
Yeah, this is maths.
P and Q and P and R.
No. P and Q or P and R.
Yes, or P and R.
Yeah, correct. Now do the same with this thing. Like, do you want? Yeah, just go ahead and derive this. Yeah. This is going to be a longer table, like horizontal.
Yeah, horizontally. And a very ugly table as well.
That's fine.
P, Q, R, and then Q or R, and then P and Q or R, and then P and Q, P and R, P and Q, or P and R. Okay, sweet. P, Q, R. Then I've got Q or R. I've got P and Q or R. I've got P and Q. Sorry, P or Q. P or R. P or Q. Oh, sorry, P and Q or P and R. I need to really drill down the and or thing. I keep splitting them both. 1 1 1 1 0 0 0 0 1 1 0 0 1 1 0 0 1 0 1 0 1 0 1 0. Q. Okay, so the V is always or.
Yeah.
Q or R. Q or R is both is true when either is true. So I'll first put the false. It's false when both are false. True in all of the cases. And P and Q or R. So that P and Q or R is true only when both are true. So I'll put them down. True, true.
If
Everything
it's
else is false.
confusing you, I mean, you can like straightforwardly write and or. वो English में लिखते हैं.
नहीं, it's fine, it's fine. I guess you should put.
ज़्यादा confusing है.
I should get used to this, right?
Yeah, आद डालने.
But it's easy for me to remember. So and is an arrow. Both are arrows, dude. I mean, like
It's upside down arrow and an up pointing arrow.
yeah. So but
Yeah,
A. So
yeah,
A. Remove that. Remove that from and arrow. Both are the same.
Right. Yeah.
Okay. So P and Q and R, both are true only when both are true. Sorry, it is true only when both are true. So this is true here. This is true here. Everything else is false. And then P and Q. P and Q is true only when both are true. So it's true here, true here, true here. Everything else is false. Then P and R is true here and true here. Everything else is false. So then this or it is true only when both the cases are when either is true and when either is true. So true, true, true. I didn't derive it properly. Something a bit wrong. Q or R is false only when both are false. So that I've done. Then P and Q or R. Q is true only when both are true. So it is true here, is true here. There we go. That's the issue I did. Okay, got it. So I flipped it. I don't know why I didn't do 0 0 0 1 1. I did 1 1 1 0 0 0.
Yeah, that's fine.
And then I got it as 3 are true and 5 are false. 3 are true, 5 are false.
Okay. Yeah. Wait. Show again. What did you? P and Q. Correct. Yeah.
Are you seeing it flipped or are you seeing it straight?
No, I'm seeing it straight.
Oh, okay.
Yeah.
Because I see it flipped.
Yeah, but it flips it for me, I guess.
Yeah.
But yeah, anyway. So
this is distribution 1.
This is distribution 1.
Okay.
So what will be distribution 2?
I'm assuming it's going to be where P or Q and R. Right?
Wait, what?
P or Q in brackets and R outside the bracket.
No.
No.
It is like instead of...
No. I got it. Instead of and, it's just or. Right?
Yeah,
so it's
everywhere.
P or Q and R.
Right.
So P or Q and R double implies. If I have to split this up using maths.
Yeah.
P or Q and P or R.
Right. Yeah. Yeah.
Sweet. I don't want to derive this right now.
That's fine. Yeah. You can do it as homework, I guess.
Homework. Okay. Homework लिख दिया मैंने. Okay, let me just. I quickly do it too. It's fine. I'm not doing homework on that nonsense. I'm a bad student.
You are the student who does the homework in class.
In class. P, Q, R, and then Q and R, and then P or Q and R, and then P or Q, P or R, and then P or Q and P or R. Okay. P, Q, R, and then Q or R, Q and R, and then P or Q and R, and then we've got P or Q, P or R, we got P or Q and P or R. Okay, so 0 0 0 0 1 1 1 1 0 0 1 1 0 0 1 1 0 1 0 1 0 1 0 1. If I don't talk to myself, I don't usually talk to myself. It's just that if I don't talk to myself right now, it'll just be me doing this for like. So I'd rather talk so that I'm entertaining the audience as well.
It's fine, dude. They'll just get entertained looking at you, man.
Q and R.
Put a full breakdown, bro.
Q and R, Rizzler hai, put a Rizzler. Q and R is true and both are true, so true and false in all of the cases. And P or Q and R is true in all cases except for when both are false, so P and, so this is false here, this is false here, true in all of the cases. So we got the negation. So P or Q and R is the negation of the previous one.
The negation of the previous one.
So this is 5 zeros and 3 ones. This is 3 ones and 3 zeros. Or 5 ones and 3 zeros.
Oh, I see what you mean.
Yeah.
Yeah, you can even you can derive this using De Morgan's law, by the way.
Wait, De Morgan's law. No, wait, one second. Negating a conjunction or negating a disjunction. I don't know how to apply De Morgan's law on a bigger statement yet.
Yeah, that's fine. We will get there.
Okay. P or Q is true when neither is true. So it's false in both of P. Q false. I think it's just true. Right? Yeah. P or R, false here. True. And it is true. Yeah, there we go, got it. Derived it properly. Killed it.
Go! Damn, yeah. That's the one.
Okay, distribution is done.
Yeah. Next one is very easy. Commutation.
What?
Commutation. Or commutativity. Commutation or commutativity.
Commutation or commutativity. Okay.
Yep. This is just going to be...
Why does commutativity sound like Andrew Tate? I don't know why. It's just a Tate in between. That's why.
Yeah.
Commutate. The state in there. Oh no. Commutation is misogynist. It's derivative for that.
Yeah. So, commutation is just you have like if you have P or Q, that's the same as Q or P. P or Q is equivalent to Q or P. You're just flipping the positions.
Yeah, right. Whereas in the case of an implication, you cannot flip the
You cannot,
antecedent.
yes.
Whereas in this case, we are flipping the antecedent. I mean, if
Yeah,
antecedent
there
is
are no antecedents and consequence here.
yeah. So P or Q implies Q or P.
Double implies.
Yeah, double implies. Sorry.
Yeah, that's
Yeah.
just commutativity number one. You want to derive it?
Nah, this is straightforward.
That's straightforward, right? Yeah. Um, okay, what will be commutativity part two? Well, like one is a disjunction.
So it'll be P and Q. It double implies Q and
Right, that's just commutativity part two.
P and Q double implies Q and P. Okay, cool.
And the last one is just double negation.
So the last replacement rule.
Right. Rule of
Okay.
replacement. It's
They're
double
all
negation.
placed. Double negation.
Yeah.
Okay.
Which is?
Which is either a conjunction or a disjunction.
No. It's only one rule.
Oh, double negation is just
one rule.
Oh, true. Yeah. Okay. It's just true.
So it's going to be P double implies not
Q.
P.
Oh, right. Yeah. P double implies not of, not P, right? Can you put this in a bracket like this?
Not P. Yeah, you don't have to put it in a bracket.
Okay. I'll just double implies not P. Like this.
Yeah.
Sweet.
Okay,
So we have got
Mhm.
6 rules of replacement, right? The first one is the De Morgan's law. Then we've got the implication. That's implication and the negation of implication. Then we've got the it starts with an A. Acceptance, no. Assembly, no. Let me just look at it. Association, starts with A. Then we've got distribution, and we've got commutation, and then double negation. Okay, so let me think of again. De Morgan's law, implication and negation of implication, association, commutation, distribution, and double negation. Okay, got it.
Oh, there's actually there are actually two more.
Two more. Okay.
Yeah.
Cool, okay.
Yeah. The first one is transposition.
Transposition. Is it a pair or is this just like double negation? It's just
no, it's a single rule.
Okay.
Yes, single rule. Both of them are single rules basically.
Okay.
Transportation is so when you have P implies Q, that implies something. So this is kind of like a derivative of the others.
Okay.
So you could have P implies Q, double implies not Q implies not P.
Oh, okay. P implies Q, double implies not P implies not Q.
No, not Q implies not P. Ulta.
Oh, okay.
Everything ulta negated.
Let me just write this again. With dirty notebook. Okay. P implies Q, double implies not Q
implies
not P.
Yeah, I think you should derive this.
Okay, so this basically, right?
Not Q implies not P. Correct.
Okay, let's derive this.
Transposition.
Okay, there we go. I have P, Q, P implies Q, not Q, not P, and not Q implies not P. So we've got 1 1 0 0 1 0 1 0, and P implies Q is false only if the consequent is false and the antecedent is true. Everything else it is true, and not Q is 0 1 0 1, not P is 0, 0, 1, 1. And again, this is not Q implies not P is false only when the consequent is false and negation antecedent is true. Yeah.
Yeah. Okay, so
So this is
that's one.
transposition.
Yeah, this is transposition.
Can I fit the next one in this space, or do you want me to go to the next page?
I guess you can go to, well,
Next
maybe you
page.
can do it in the same page.
Okay.
So it's called exportation.
Exportation. Okay.
So exportation is going to be P and Q imply R,
P and Q implies R. Okay.
which double implies
Which double implies
P and Q and R. Sorry, P implies Q implies R.
P
So
implies Q implies R.
yeah, so and the Q implies R is in a bracket. P
Okay.
implies Q implies R.
So P and Q implies R
Hmm.
is is equivalent to P implies Q implies R.
Right. Now
Okay, so
derive
let's quickly
this.
derive this.
Yeah. That will be the end of rules of replacement.
Succeed. Somebody joined. The same person from before.
Hmm.
P, Q, P and Q, P and Q implies R, Q implies R, P implies Q implies R. Okay.
Right. So you've derived that too, right? Okay.
I'm deriving it as
Okay.
this.
Okay.
So P, Q, P and Q.
Pile,
This
can
is
you mute your?
P and Q implies R, Q implies R, P implies Q implies R. Okay. And we've got 0, 0, 1, 1, 0, 1, 0, 1, P and Q, 0, 0, 0, 1, P, P and Q implies R. So P and Q is in brackets. Could be, doesn't have to be, right?
It does have to be in a bracket.
Okay. So P and Q in brackets implies R. W implies, P implies, Q implies R in brackets.
Hmm.
Right? So P and Q implies R. Will be true only, will be false only when the consequent is false and the antecedent is true,
Hmm.
which is in none of the cases. Wait, no, sorry, in the third case. Am I doing this right? Yeah.
Aputa sparrow sucks.
Yes.
Yes.
And then Q implies R is false only when this is false. So it's true in all other cases. And P implies Q implies R will be true, will be false. Only when this is false. Wait, P implies Q. Anyway, I haven't derived it properly. Okay, I've done some mistake. Q, P and Q.
Hmm.
It's true only when both are true. So that I've done. So P and Q is correct.
Hmm.
And then P and Q implies R is false only when the P implies Q. Oh, I haven't put an R. That's the heck why. That's why. That's why. There's no R. Like, how would I have derived it properly?
Oh, damn.
I'm like, something is off. Okay, let's do this again.
It's fine. You can do it on the next page. There is one more like very simple Chindi rule called tautology.
Oh.
Like I was going to skip it, but since you're going to next page, might as well do that.
Yeah. Okay. Okay, so we're doing P, Q, and R, and then we're doing P and Q, and then P and Q implies R. Then we're doing P implies Q, and P implies R, and then P implies Q implies R. Correct? So we know P and Q are not in brackets. Q and R in the brackets. Okay. 0 0 0 0 1 1 1 1 0 0 1 1 0 0 1 1 0 1 0 1 0 1 0 1. P and Q, it is true only when both are true. So obviously the last two and everything else is 0. P and Q implies R is false only when the consequent is false and the antecedent is true. So only in this case, everything else it is true. P and P implies Q is false only when only here and here. It is true in all of the cases. P implies R is false. P implies R is false. Sorry, I forgot. Implication is false and the consequent is false and the antecedent is true.
Right.
I gotta keep reminding myself. P implies R here. And here. Everything else is true. And then P implies Q implies R. So why did I do P implies Q? Nonsense. Okay, doesn't matter. I've done it anyway. P implies Q implies R. P implies, and I didn't do Q implies R. I did P implies Q implies R. Okay, just split the columns. I'll make this is Q implies R. I'll make this P implies Q implies R. Okay, Q implies R is false only when here and here. So I think that's it is true. And P implies this asshole is going to be. Dude, this is so far away. Where is okay? Q implies R is here. P implies this is going to be false only when 1 and 0. So this here. Everything else is true. Yeah, there we go. I derived it. Derivation. Okay, so PQR,
Right.
P and Q. P and Q is true only when both are true. So both are true here. And then P and Q implies R is false only when antecedent is
False.
P and antecedent is false. Sorry, antecedent is
True.
true and consequent is false.
False.
So that is here. And everything else is true. And then P and Q, I don't know why I did. P and R, I don't know why I did. Here is Q and R. Q implies R is false only when the antecedent is true and consequent is false. So two of them. Everything else is true. And P implies Q implies R is again going to be false only when this is false, but here in P this is true. So it's also false. So that means this is true, and this is true, and this is false. So that means this is false. So everything else is 1.
Right. Yeah.
Okay, so this is exportation. Okay, exportation. And then we've got the last one you said is tautology, right? Tautology. So we've got De Morgan's laws. We've got implication laws, the implication, negation of implication. We've got association. We've got the Andrew Tate one, that's the constantation.
No, commutativity.
Commutation. Let's say constipation, almost right. Commutation. And then we've got the thing which starts with D.
Distribution.
Distribution is given. Distribution, and then we got transposition, and this one that we just did, that was exportation.
Right.
Then we got tautology.
Yeah. Transposition is also called contraposition in some books.
Contraposition.
Oh, there are actually two more. Tautology. Have we done already?
Yeah,
No.
we're going to do tautology right now.
Right. So actually, before tautology is very easy. Tautology is just P double implies P and P. That is the first one. Second one is P implies P or P.
We've already done tautology before, but we didn't do it in this way. We just
No,
P
that was P
and-
or not P.
P or not P. Yeah.
That's also a tautology.
Also, this is a tautology in specific only with rules of replacement.
No. Even like it's a tautology is a tautology when it's always like when the truth table is always true.
Yeah. Right.
So here it is P implies P and P.
P implies P and P.
Yeah. And then you have P. The second tautology rule is P implies P or P.
P implies P or P. Okay. That was Bodoga.
Yeah.
Bodoga. Yeah, I didn't realize. Not a surprise. Okay, so P implies P or P. Okay. Should I derive this? Let's derive this. P.
You don't need to derive it. You can we can go to material equivalence.
Okay, I'm just quickly deriving it.
Okay. I mean, it's straightforward, this thing, commutativity.
Yeah. P and P or P. Then we've got P implies P and P, and we've got P implies P or P. So 0, 1. P. I had to put another P instead. So there'll be two rows of P, both are 0 and 1, right? I can't change them. P and P will be here. P or P will be again the same thing. P or P and P are the same thing.
Yeah.
Okay.
They're
so
both
P
tautologies.
implies, wait, what? P and P or P aren't tautologies. P
and P is a
what do you-
tautology.
No, wait, so I did this way. I did 0, 0, 1, 1, 0, 0, 1, 1. So P and P is 0, 1, P or P is 0, 1. Okay.
P.
So P and P 0, 1, 0, 1. P and P would be where both are only true only and both are true.
Right.
Here 1, 0. And P or P both are false. So 0, both are true, 1. So they aren't tautologies, but they're the same. They're equivalent.
Yeah.
Okay. And then P implies P or P would be again, this will be a tautology. Yeah, because both are true. And P implies P or P implies P or P, again it's both are true. Because it's never false. It's going to be false only when the consequence is false and the answer is true, which is never the case. Right. So this was tautology. And then what's the last one you said?
Material equivalence. So it's the same as biconditional. So you had one set of rules for implication, right? Implication and negation.
Implication and negation.
Implication and its negation was one category.
Yeah.
Like that, we have one for biconditional, like double implication.
Oh, okay.
So you have P double implies Q.
P double implies Q.
Double imply which double implies?
So P double implies Q in a bracket.
Right.
The whole double implies.
So what is a biconditional? It's a conditional going both ways. So what would that be?
So Q implies P. Q double implies P.
Q double implies P. Yes, but you're doing here you're doing commutation. What I'm saying is like
Oh right, yeah.
yeah, but what I'm asking you is like what is it's a biconditional going in both directions. Like it's a conditional going in both directions. So that means P implies Q and Q implies P. So P double implies Q means P implies Q and Q implies P. We derived this before.
Possibly, yeah. We just derived so many things I just lost track of what we derived and what we haven't. Oh yeah. That's how we discussed by condition in the first place.
Right.
So P implies Q and Q implies P. Right. So I'm not deriving this because we've already derived it before.
Yeah.
It's PQ, P implies Q. Okay. Got it. And then is this also double rule or is this just one rule?
No, two rules. So it's P implies Q again. Double implies.
Double implies Q.
Yeah. Which whole implies? Whole double implies. P and Q.
P and Q.
In a bracket.
Alright.
Then or. Not P and not Q.
In a bracket. Not P or not Q.
Not P or not Q.
Not P or not Q.
Not P and not Q.
Not P and not Q.
This is again, you can just look at our truth table.
So this is right? So P double implies Q, double implies P and Q, or P not P and not Q.
Right, yep.
Okay.
So this again, you can just look at a truth table. Like if you just look at the truth table definition of P double implies Q, it's going to be true when both of them are true.
Right.
So when both of them are true or both of them are false.
Right.
So the first half, like it's a conjunction, which means both of them are true or both of them are false. Getting the second rule?
I got it.
Yeah. So that's what those are the two material implication. Material equivalence or biconditional.
Right.
So yeah,
with rules of replacement, there are 10 rules of replacement. The first one is De Morgan's law, where it's just negation of conjunction, negation of disjunction, where it is not of P and Q is not P or not Q. Not of P and Q is not P or not Q. Not of P or Q is not P and not Q. So we've completely negated it. And then negation of implication, where it is negation of P implies Q, double implies P and not Q. This we derived as well. And then what's the next one?
What all have you named?
Negation of implication I've done, and implication we've done, right? So P implies Q is not P and Q.
No, or Q.
Yeah, or Q. Sorry, not P or Q.
Yeah, P implies Q is not P or Q.
Not P or Q. And not negation of an implication is P and
P doesn't imply Q.
Yeah, P doesn't imply Q. Negation of P implies Q is P doesn't imply Q is P and not Q. Then we call association, where the brackets just change. Where in P and Q and R in brackets, W implies P and Q in brackets and R. Or P or Q or R in brackets, W implies P or R in brackets or R.
Basically the same rule with
Just shifting the
just
brackets.
shifting the brackets. Yeah,
Yeah.
between like so there
Yeah.
are one rule is for disjunction, one rule is for conjunction.
Conjunction, yeah. Then we got distribution where P and Q or R is P and Q or P and R. P and Q or P and R.
Right.
And the second distribution is P or Q and R in a bracket is P or Q and P or R. And then we've got commutation, just P and Q is Q and P, or P or R, P or Q is Q or P. Then you got the double negation, is P double implies negation of P. And then you got the transposition or contraposition. You got P implies Q, double implies not Q, implies not P. Then we got exportation, where P, okay, this I got to remember. Oh yeah, this is easy. Exportation is P and Q implies R. Is double implies P implies Q implies R.
Right.
P implies Q implies,
Q implies R. Right.
And then a tautology will be P implies P and P, and P implies P or P.
Right.
And then we've got material equivalence, which we just did right now, is P double implies Q, double implies P implies Q, P double implies Q, double implies P implies Q, and Q implies P. And P double implies Q also double implies P and Q, or not P and not Q.
Right.
Okay.
Okay.
Got this.
So we have
Just-
done 10 rules of replacement.
Yeah.
Next time we'll be doing rules of inference.
Mhm.
And there aren't many rules of inference, but I guess the next session will be rules of inference, and then the one after that we'll practice doing some proofs.
Sweet.
Where we will combine rules of inference and rules of replacement, everything. Basically everything you've done, you'll apply in proofs.
Okay, got it.
Yeah.
Awesome.
Cool. Well, catch you on Thursday then.
Day after tomorrow, yeah.
Yeah, cool. Yeah.
Bye.
Bye.